This next part of the lesson, we're going to solve radical equations. Radical equations are things with square roots or cube roots or fourth roots. They are things with a root. So a square root looks like this, but a cube root looks something like that. Fourth root, whatever, there is an index in the little crease of that root, which is a radical symbol. And the inside of the radical is called the radicand. But when we're solving these equations, we want to first isolate the radical on one side of the equation. If we happen to have more than one radical, then we want to choose one of those radicals to isolate and start there. We can raise each side of the equation to the reciprocal power so that it will get rid of that radical. It'll eliminate the radical. Now, reciprocal is just a fancy word for a flip. So the reciprocal of 1/2 is 2/1. Just give yourself an example here. 3/4 reciprocal would be 4/3. If I have -2/5, its reciprocal would be -5/2. Reciprocal just means that we are flipping that fraction. And then once we have that, we will solve the resulting equation. Sometimes there's another radical, which we might have to repeat some steps. But the biggest thing for radical equations is that we need to check for extraneous solutions. Extraneous solutions, there's a fancy word there, but it looks like we have extra solutions, which does happen sometimes. When I plug those back into the original equation, sometimes our solutions don't actually work, and that has to deal with some domain issues. Let's look at this first example. I've got the cube root x minus 5 plus 1 equals -1. So the very first thing we want to do is isolate that radical. We've got a cube root, but that 1 is not inside the radical. So let's move that to the other side. We move it by subtracting 1 from both sides. So that gives me the cube root of x minus 5 equals -2. And we're going to get rid of the cube root. We get rid of the cube root by cubing both sides. Cube and cube root are opposites, so it leaves me with x minus 5 equals a -8. -2 cubed is -8. Now I'll solve this equation. So x equals, let's move the 5 over. I get -3. Now I don't want to stop here. I do want to check my actual solution. And you can check this by hand or with your calculator. So I have the cube root of -3 minus 5 plus 1. And we're seeing, does that equal -1? Well, -3 minus 5 is -8. So we're taking the cube root of -8, adding 1 to it. The cube root of -8 is -2. -2 plus 1 is -1. And -1 is -1. So that answer does check out. If you have a calculator that is a scientific calculator, it kind of looks something like this. There's a cube root button, but there's also a button for you to do a fourth root, fifth root, whatever. So the actual square root button is above the x squared one. You would hit second x squared, and there's your square root. But for a cube root, we need the one above that. So second, and this little x to whatever power. It does automatically make this a answer button if you don't have anything previously typed. But you can go to the left and change that to a 3. The cube root of -3 minus 5. Go outside of that cube root and add 1. We do get what we are supposed to, -1. All right, let's look at number 2. X equals the square root of 56 minus x. The square root, or the radical, is already isolated. It's by itself. If I look at the right side of the equation, there's nothing else there. It's just the square root. So we want to undo that square root by squaring both sides. All right, so x squared is going to be on the left side. The square and the square root cancel out. They're going to give me 56 minus x on the right. And this became a quadratic equation. That's one thing to hopefully notice throughout this course, is realizing what type of equation we now have. This was radical and it turned into a quadratic because we have an x squared equation here. And I just solved quadratic equations, so we want to get them equal to 0. I would move the x over by adding x. I can move the 56 over by subtracting 56. And then we factor that quadratic. We're looking to use that zero product property. So x squared multiplies or became x times x. And we're looking at factors of 56, which are 8 and 7. This would factor into x plus 8, x minus 7. The zero product property said to set each factor equal to 0, which means x is equal to negative 8 or x is equal to 7. We don't want to stop here. We want to check our work. So we're going to check both solutions. We check it by going back into the very original equation. So I'm going to say negative 8 equals the square root of 56 minus negative 8. 56 minus negative 8 is 64. And the square root of 64 is 8. But negative 8 is not equal to 8. So this is one of those extraneous solutions. We need to make sure we're looking and checking our work, because negative 8 doesn't actually work. If I tried 7, x equals, so 7 equals the square root of 56 minus x, so 56 minus 7. Well, 56 minus 7 is 49. Square root of 49 is 7, and 7 does equal 7. So that one does work, but negative 8 did not. All right, and let's jump to number 3. X equals the square root of x plus 10. And then outside the square root, we have this plus 2. So the first thing we want to do is isolate a radical. To isolate a radical, we can subtract 2 to both sides, which is x minus 2 equals the square root of x plus 10. Now we need to get rid of that radical by squaring both sides. The big thing here is that we are squaring everything on the left. That whole thing is x minus 2. And when I square it, we're saying this is x minus 2 times x minus 2. Something squared is being multiplied by itself. The square root is gone, so I just have x plus 10 on the right side now. But this x minus 2 times x minus 2 needs to be expanded out. This would multiply to give you x squared, a negative 2x, and another negative 2x. Negative 2 times negative 2 is positive 4, which simplifies to x squared minus 4x plus 4 equals x plus 10. So we did get a quadratic equation. This quadratic equation needs to be set to 0 so that we can use that zero product property. I'd move that x to the other side by subtracting x and subtracting 10. So x squared, if I subtract x, negative 4x minus x would be negative 5x. And then subtract 10, 4 minus 10 would be negative 6. We get a quadratic equal to 0. It's not factored, but it is getting closer to the solution. So we factor that quadratic expression. This would be x and x minus 6 and plus 1. So we want to double check things just by multiplying it back through. X times x is x squared. On the outside, we get positive 1x, and on the inside, we get negative 6x. 1x and negative 6x does give you negative 5. And when I multiply negative 6 and positive 1, it still gives me negative 6 there. So that's our factored form. We set the factors equal to 0. And we get x equals 6 and x equals negative 1. Again, we need to check our solutions. This time I'm going to use my calculator to check just to see what we got. All right, so 6, when I plug it in on the left, is just 6. On the right, we have the square root of 6 plus 10, and then outside plus 2. So the right side equals 6, and the left side was 6, so that one does work. Now let's check the other one. We have negative 1. That means the left side is going to be negative 1. Let's see if the right side is negative 1. We get the square root of x, so negative 1, plus 10, and then plus 2 on the outside. That equals 5. So our equation is saying negative 1 on the left and 5 on the right. This is not going to work. That's an extraneous solution because it doesn't satisfy the original equation. We've got 2 more here. So I'm going to go to number 4, but there's a little bit we need to discuss about this. This may not look like a radical equation, but that's because we have a rational exponent. So rational exponents if we look back at that definition, it's a fractional exponent. X to the a over b can be rewritten as a radical expression. This would be b root. So the b root, whether that be a square root, cube root, fourth root, or whatever, the denominator of that rational exponent becomes the root. And then we have x to the a power. So it might see something like x to the 1/2. X to the 1/2 is a square root of x to the first power. Because it's a square root, we don't really write the 2 here often, but that square root does have a little implied 2 in the crease. X to the 1/3 power would mean I'm taking the cube root of x to the first. If I had x to the 2/3 power, this would be the cube root of x squared. So these rational exponents do create radicals. When I look at number 4, it is actually a radical equation. So I want to isolate this radical by taking or getting rid of the 2, because the 2 is not attached to that exponent. The exponent's only going to those parentheses. So let's undo that 2 by dividing by 2, which would say x minus 4 to the 3/4 power equals 27. Now we can undo this rational exponent by raising both sides to the reciprocal power. That will eliminate this radical. The reciprocal of 3/4 is 4/3. This works because of that power to a power property of exponents. So when you had something like a squared to the 5th power, with a power to a power, you're multiplying those exponents, which makes that a to the 10th. Here we're multiplying, let me just write it underneath. We have x minus 4 to the 3/4. and it's being raised to the 4/3. Oops, let's bring that up so you can see it. If I had a power to a power, we're multiplying, we're figuring out what is 3/4 times 4/3. Well, ends up being 12 over 12, which is just 1. And that reciprocal power does always give you 1 if you're working that out. So that's why we wanted to raise it to the reciprocal power, because it would just be x minus 4 to the first. So we have x minus 4, which is equal to whatever 27 to the 4/3 power is. You can use your calculator for that. But 27 to the 4/3 is 81. Now I can just solve for x. Add the 4 to the other side, we get x equals 85. Again, we're not guaranteed that that's the actual solution. We need to check for extraneous solutions. So I can check that by plugging it straight back into my calculator, or by doing it by hand. It may be a little bit harder to do by hand, so let's use the calculator. We have 2 parentheses x, so 85, minus 4, and it's raised to the 3/4 power. It does equal 54, so we know that we have a correct solution. Lastly, we've got one more. We've got number 5. For this one, I usually see some algebra mistakes. So we have 14 minus whatever we have here, this 5 minus x to the 1/3 equals 12. I need to undo this 14, but this is a positive 14. We're not doing minus 14. We're doing 14 minus something else. So to undo that 14, I would subtract 14 from both sides. 14 minus 14 is 0. It leaves me with negative parentheses 5 minus x to the 1/3 power equals -2. This negative out front is like you have a -1 there. -1 times 5 minus x to the 1/3 power. So we're going to undo that by dividing by -1. We get 5 minus x to the 1/3 power is equal to a +2. Again, we're going to use the reciprocal power. So the reciprocal is 3 over 1, or just 3. So I'm left on the left side with 5 minus x. On the right side, we have 2 to the 3rd power, which is 8. So 5 minus x equals 8. I can subtract 8 minus 5 is 3. Divide by -1, we get -3. Again, we're not guaranteed that that works, but we can check it with our calculator. So I'm going to go in here and see 14 minus, and then parentheses, 5 minus x. So 5 minus -3. The whole thing in the parentheses is raised to the 1/3 power. We want to see, does this equal 12? And it does. So we know that this is a correct solution. Remember always with a radical equation that you're going to need to check for extraneous solutions.